Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Synopsys. My name is Cody, and welcome back to Techstrong Learning. Before we dive into this session, we do have a couple of notes to review. First of all, we are recording this session today, so if you happen to miss any of our conversation, if you'd like to watch again later, or if you'd like to share with the rest of your team, we'll be sure to send you the recording via email shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you do have specific questions for Mike, I do want you to submit those to that Q&A box. We'll do our best to answer as many of your questions as we can today. So please do send those in and we'll touch on them toward the end of our session. Additionally, we have a couple of polls we'll be launching throughout our program, so keep an eye out for those as they pop up. And if you jump to the handout section, you'll see there are some resources there for you, as well as our presentation slides, so feel free to download those to follow along. Finally, I will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, send in your questions, and to fill out our survey following the webinar. That is currently linked in the handouts, but I'll post a link in the chat toward the end of our session as well. So without further ado, today we're going to discuss the 2024 Guide to Open Source Security and Risk. I'm joined today by Mike McGuire, Senior Software Solutions Manager at Synopsys. So Mike, I will turn the program over to you and let you dive right into it. Thank you so much for joining us today on Techstrong Learning.
Okay, thank you, Cody. Hi, everyone, and thank you all for joining. I see a few comments here. We've got some attendees from Germany, Las Vegas, India, Finland. Fantastic. I'm joining you from the greater Boston region, East Coast, starting to warm up. It's April, so we expect a little bit more rain, wind, some cold weather. Don't rule out snow yet, not until Memorial Day, I like to say. But nonetheless, that's where I'm coming from here. Haven't had time to work on my tan yet. But I'm here to talk to you today about open source security and risk in modern applications, commercial applications, and enterprise applications. Any application that you build or interact with probably has open source in it, and we'll dive right into that. So we're here to talk about some of the risks that introduces and that you should be possibly concerned about, at least accounting for. So this is what we're going to cover today. Why are we so focused on open source today? And what's the prevalence of open source throughout all of the applications that we build and interact with on a regular basis? What are the risks that open source brings into an application? What makes this type of risk unique from any other sort of software that our teams build or our teams leverage? Then we'll dive into the actionable part and talk about best practices for open source risk management. And then we'll see if there's any questions or any comments. And as mentioned by Cody, we'll sprinkle a couple of polls in there too to see where everybody is at with their open source programs. So before we really get into findings, let's talk about our data sources, because what I'm going to discuss, the findings that I'm going to discuss today, come from our Synopsys' annual open source security and risk analysis report. From here on out, I'll refer to it as the OSRA report, but we publish one of these every year. And where we get the data from that is from our audit business. So there's 2 sides of the business that we have here. We sell products that our customers can subscribe to and use as a SaaS product or even host it on premise. Or they can come and hire our audit business to come and run the tools for them. Now, our audit business is going to be used mostly in the context of a merger and acquisition. So if I am acquiring your company, then I want some idea of the risk that the software is going to be introducing to the deal, especially if the software is a significant part of the deal value or the asset of the entire company. Now, you don't want to give me your source code because I haven't purchased you yet. For all you know, I might be a competitor. So what I will do is hire Synopsys, who will go in as a trusted third party and audit your software, come back to me and tell me what types of risk are involved in those applications and that software. Now, what we do here at Synopsys is we scramble that data up, make it anonymous, and then we compile it in a manner to put in a report and send out to our customers and everybody in the application security market so they can have a good idea of the current state of open source in modern applications. So you'll see on this slide the industries that we audit in. We don't have a favorite industry, but obviously the distribution is going to skew towards the industries where there is more tech transactions taking place. Obviously, you can see that the vast leader is the enterprise software and software as a service. And my speculation on why that is so high at this point in time is pretty simple. It's the fact that every company is a software company. So it doesn't matter if your business is software, all right? It doesn't matter if you're selling software at the end of the day, or you're doing something completely different like e-commerce, or insurance, or financial, or something completely unrelated. You're probably using software to enable your business and enable your customers. And you're probably doing a lot of in-house building of this software as well, because you need to tailor it to your specific needs. So that top category up there for industries, that's going to be referencing all of those, all the latter of that situation, which is why that number is so high. But we do have a statistically significant representation of all the industries that we provided audits for. We ended up auditing 1,067 code bases this year. That's down from over 1,700 last year. And really, that just comes down to the state of the economy and where tech transactions are at right now. Money is very expensive to borrow at this point in time, as I'm sure everybody here is aware. So transactions are down a little bit, but over 1,000 code bases analyzed, again, is a paints a very, very accurate picture of open source usage and in modern applications. 88% of that 1,067, those code bases underwent a risk assessment. So from here on out, any numbers that I share with you about license risk, security risk, and quality risk are going to be 88% in that 88% bucket of that full 1,067 numbers. So why are we so focused on open source software? Why do we do a whole report year after year on open source software? Why am I sitting here doing a webinar on open source software? Now, half of me thinks, or a lot of me thinks, that you probably already understand why, and that's why you're in this webinar, viewing it as I speak, but let's cover it anyway. Well, software supply chain security is very, very top of mind. And you can't talk software supply chain if you're not talking open source software, right? Open source software, by very definition, is written by somebody else, by some third party, outside the visibility and the control of the organization that's leveraging it. So they are taking on a lot of upstream risk from their software supply chain. Now, we can sort of see the impacts of that, of unmanaged open source risk, if we think about Log4Shell, if we think about Apache Struts, which is the open source library that had the vulnerability that impacted Equifax, a recent curl vulnerability, OpenSSL, recent vulnerability. Now, I want to acknowledge open source isn't all of the software supply chain. We're starting to see some increase in more complex risk or complex attacks like those that impacted SolarWinds, malware injection, if you will. But open source is going to make up the vast majority of your software supply chain efforts, your concerns, and so on, right? We're starting to see that the injection of malware into a direct development pipeline is rare, but we are seeing a lot of attackers injecting malware directly into the open source ecosystem with NPM, malicious packages within GitHub that I was just discussing with Cody before this. So again, open source is a huge vector for software supply chain risk to enter an unsuspecting application. And that is why we are so focused on it. Now, we're not the only ones focused on it, right? Almost all of the code bases that we analyzed and we audited contained some sort of open source. 96% contained some sort of open source. And this was true across every single industry, right? Because as I mentioned previously, every company is considered a software company. Everybody is using software or open source software. And it's not just a little bit of open source software, it's a lot. So that 77% number that you see there, I like to call that open source saturation, if you will. So if you took every line of code that we audited and put it in one file or one sheet of paper, then 77% of that source code originated from some sort of open source project. So just over 20% was written in-house, proprietary, commercial, written by some contractor, whatever it may be. But obviously the vast majority of it is open source in origin. So no matter who you're talking to, if they build software, they're using open source. You can say that confidently. I know it's not the 100%, but we can make some assumptions here, usually based on who we're talking to. Usually when somebody tells me they're not using open source, I make them prove that, right? It's sort of like the guilty until proven innocent approach there, if you will. Now, how does open source even get into an application? I want to cover this because it's very important to set up my next slide here. The easiest way is package managers. So these are the open source dependencies that development teams intentionally bring in. They're actually asking a package manager to bring in a specific open source library or dependency. And what that package manager is going to do is it's going to go get maybe the most recent version for it. It's going to go get the transitive dependencies. So it's going to get the dependencies of the dependency. It'll bring those in. Perhaps it'll keep your dependencies up to date, whatever it may be. But that's the easiest way. And that's going to take care of most of it. But there are some other areas that usually fly underneath the radar. If you look lower right, there's dependencies that simply are not found in package managers. The most simple example is think of C and C++. There is no standardized package manager for those languages. Open source can be linked directly in a project directory, or it can be linked in a header file from some sort of outside directory. So if you're just interrogating a package manager, you're not going to really have a clear view of the open source that's included in these applications. Same with container images, right? Container images are made up of several different layers, and it's hard to understand exactly which open source dependencies impact each one of those layers. Top right in green there's always some sort of binary library, artifact, or container that might be brought in from a third party that a development team might not have the access to source code or build environments for, which means, again, there's no idea of what open source is flowing into the application. And of course, code snippets. Now, there's sort of the old view of code snippet and the new view. So if you look at the old view, this is something that I did. I cut my teeth as a developer. And if I needed something, some sort of algorithm, say I wanted to build a quad tree, I certainly wasn't going to do it from scratch because I know somebody else invented this wheel already. So I Googled it and I went over on Stack Overflow and I found what I needed to, and I copied it directly from there and pasted it into my application. Now I completely had no idea, because I was a junior developer, that there were license obligations associated with my code. This was not my IP. I couldn't just take this and put it into a commercial and a distributed application without at least adhering to some Creative Commons license, which means perhaps not using it commercially, giving it attribution in some sort of notices file. Now that was the old way of doing it, but this is made even easier now with AI coding assistants like GitHub Copilot and ChatGPT, OpenAI Codes, where you just prompt the AI and it brings in blocks of code for you. Now, these LLMs learned from open source projects, And while they do try to change and alter the source code that they provide, oftentimes it's not different enough to actually evade the IP obligations from the project that it came from. As a matter of fact, we did in a little experiment here at Synopsys where we ran our snippet analysis on AI-generated code from GitHub Copilot, and we were able to match it back to the open source project from which it originated, and we found out that it had a GPL license, which was a very restrictive license. So had we actually built that into our applications and shipped it and got caught, we could have been on the hook, and our IP could have been in serious jeopardy having to make that open source for everybody. And that's no good, because we need our IP. We build software. That's how we build money. So keep this in mind. Think of all the ways, all the avenues and channels for open source to enter an application. And it sort of makes you think twice about whether or not you have a decent grasp on how much open source is being used within your organization. Now, with that being said, I'm going to kick off the first poll here. Hand it over to oh, here it is. Just think for a second. How many open source projects do your teams depend on to build applications? I won't hold you to it. I just want to see where everybody's head is here, right? There's you just don't think your teams use open source at all. Maybe you use a little, 50 dependencies, 51 to 100, or you use a lot, 101 dependencies to 200, or vast amounts of open source, over 200 dependencies. So give that a little think. I'm going to click do it later here because I already know the answer. Let's see, we'll go over to poll. All right. All right, what do we got here? All right, 8%. No, we don't use open source. Okay, if you say so. Oh, we're down to 6%. Somebody changed their number, or maybe not. 53%, over half of my attendees here say they use less than 50 open source dependencies in their applications. 24% are saying 51 to 100. 12% are saying 101 to 200. And then only 6% are saying more than 200 or 201 or more dependencies. Cool, very good. I like this. There's some good honesty here. Well, let's go to the next slide here. In our research, we found the average open source, or I'm sorry, the average modern application uses 526 open source components, 526 dependencies in a given application. Now, remember, this is the average. So by definition, half of our code bases that we analyze use less than that, and half actually use more than this. You're probably thinking, how can this happen, right? How is this possible? And it's really quite simple. Invisible or transitive dependencies, right? This is how your grasp on open source usage within your applications can immediately become inefficient, insufficient, and your open source management approach can be wildly out of control, right? So the reason for that is, kind of have this image, it's grayed out in the back here. What that is that's a dependency graph for a very popular NPM component. You can't see it, but at the very, very middle is a green dot, and that is the direct dependency. So as a developer, that's the one that I want to bring into my application. Everything attached to it, so big that I couldn't even fit the image on the screen, everything attached to it is the transitive dependency to that particular application. Now, we could go on and on and on, but you even see the transitive dependencies of transitive dependencies. So just from needing that one specific dependency or project or library that I brought in intentionally, I'm also bringing in all these other components, and they can be very, very difficult to track. Some of these dependencies might not even really show up in a package manager in your pom.xml or your package.json file. Some of these dependencies may be dependent on the environment in which the end application is going to be running. So you can see here how we easily creep up to that 526 number right there, and why a lot of folks that we speak to just don't understand that they have this many components. As a matter of fact, most people we talked to said, no, that's everybody else, but that's not me. We did a little survey a couple of years ago with the audit business, and it turned out that we actually asked this question of our clients, and the understanding of the person in charge of this sort of knowledge, they usually were off by 50%, right? So they had twice of the open source that they actually thought. So whatever you think, probably double it. And that's the number of open source dependencies they have in your applications. So what's the issue with this though, right? Is this really a problem? SaaS is king, which means if I'm building an application, I am managing the infrastructure. I'm hosting it. Memory's cheap. Who cares about bloated apps, right? Who are you? Who is my customer to care about bloated apps? If there's a bloat issue, it's my issue. Why should I care? And the answer is forgotten unmanaged dependencies lead to security issues, right? You can see in our findings here, 91% of the code bases we analyzed, they were 10 versions or more behind the most current version. You cannot stay up to date with patches with this many open source components, right? Almost half of the code bases, right, we're using components that had no new development in the last 2 years. These are projects that have lost community and development support. Now, in all fairness, the organizations that owned the usage of these open source components probably aren't really actively using them anymore. They're just pushed off to the side. They're in a library, but you still have to think, is this library accessible by some sort of code call stack? Or is it even accessible by user input, perhaps? Because this is what really creates a blind spot that can go in and severely damage an organization. Now, I alluded to security risk because that was sort of what we talk about security or operational risk, but that operational risk is looming security risk, and clearly we find plenty of that. 84% of the code bases that we analyzed had some sort of vulnerability. Now, that's not a huge concern to me because vulnerabilities are just part of the business. You build software, there's going to be bugs, and a lot of bugs turn into security vulnerabilities. Not all vulnerabilities are created equally, right? Not everyone is going to pose the same amount of risk as another one. Some might not even have proven exploits. Some might have very low CVSS scores. Some might require very, very specific access to an application, so it's not that big of a concern. Now, my main concern is that 74% of code bases that contain high risk vulnerabilities. So these are ones with high severity scores and usually with exploits available. Another concerning figure that's not pictured here on this slide is the average age of a vulnerability. The average age of a vulnerability was 2.8 years old, right? So the average age of vulnerabilities floating around in all these code bases, almost 3 years old, unfixed. And a solid example of that is the fact that we're still finding vulnerable versions of log4j, right? 9 of the code bases still had vulnerable versions of log4j. That is a very old, but a very severe vulnerability that has easy fixes available. So why are these still lingering around? Is it because organizations just don't care to make the fix? Maybe not, right? It all just comes down to the inability to manage dependencies. It all comes down to visibility. And as a result, you get vulnerabilities. Now let's take a look at a specific vulnerability example. I want to deconstruct one a little bit here. So we put together top 10 vulnerabilities, right? There's 2 top 10 lists in the OSCE report. There's the top 10 most common high-risk vulnerabilities and the top 10 just most common vulnerabilities that we find in the code bases. This one is from the latter, CVE 2020-11022, and it was found in 1/3 of the code bases that we analyzed. Let me repeat that so I can let that sink in. This was found in 1/3 of those almost 1,000 code bases that we analyzed and did a risk assessment on. Now you can see here, this is a screenshot from one of our software composition analysis solutions, which gives a breakdown of the vulnerability. That this is a high severity vulnerability with a score of 8.6. And the kicker is there's a fix available. So there's a fix available, but we're still finding this unpatched in a lot of the code bases that we analyze. Now you could argue that maybe teams can't upgrade. It'll have downstream impacts. But if you look at the impacted versions are 1.2 through 3.5. But we are now on version 3.7. So I'm going to go ahead and say the argument that teams can't upgrade is a little bit moot. We've been on 3.7 for a while. We're actually almost going to be going to, I think, the next major version of this jQuery library as well. So the more likely explanation of why we're seeing this vulnerability hanging around is visibility issues, right? Not understanding that this vulnerability is impacting a specific code base. Now, also, I want to turn your attention to the CWE, or the common weakness enumeration, which just classifies the type of vulnerability. Now, the CWE for this is 80, CWE 80, which is improper neutralization. And this maps to CWE 707, which is the pillar vulnerability. It's basically the pillar CWE for this particular CWE. So CWE 707 is going to have a broad set of different types of issues, and CWE 80 maps up to it. Now, I'm telling you that for a reason. Keep that in mind, CWE 707. Now, these issues that are underneath CWE 707, these types of issues are very, very easy to make, right? Any developer from any sort of experience can make these types of these issues. They're also very easy to exploit and very hard to spot. So you can kind of see why these pop up so often. This is a very common type of vulnerability. But the kicker is they're very and usually very easy to fix. So they're easy to fix. We see a fix available. And so why do we see it here so often? And why do we see the same type of vulnerability in our top 10 vulnerabilities? All right, you can see 8 of the top 10 vulnerabilities that impact the code bases that we analyzed all map back up to CWE 707, which is improper neutralization. So basically, poor data sanitization. Now, I can go on and on and on about maybe it's just difficult for developers to understand the flow of data through an application, which I think is very true. Maybe it's difficult to understand when you leverage an open source dependency that's going to be handling input. You don't know whether that's going to be doing data validation or sanitization, which I think is very true. But I do think there is a more simple explanation, right? I can't remember whose razor is it when they say the most simple explanation is the most likely one. So we're going to go with that person's razor. It's not Hamlin's razor, is it? I don't know. If somebody knows, you can put it in the comment box, and then that gives you a better opportunity to get your $50 Amazon gift card. So the more likely issue here is if we consider the library that is the biggest troublemaker here, and that is jQuery. Now, jQuery isn't a insecure library. It's just a very common library, but it's one that developers don't interact with every day. It's sort of a supporting library, right? By very definition, it takes big JavaScript functionality and it condenses them into very few lines of code. So it's very, very powerful. Everybody's using it, but developers aren't usually saying, you know what, I want to intentionally pull in jQuery 1. Whatever into my application, right? They know they need some sort of functionality. They let the package manager hash that out, and then jQuery comes in and then pulls in tons more dependencies because, again, by very definition, it's actually by very definition, it's sort of condensing all of this functionality of JavaScript, so it needs all these dependencies. So when you bring in one jQuery, it's like feeding a stray cat, right? It brings in all the other dependencies and all the other stray cats that heard that there's a free meal on. So that's why we're seeing this, right? It runs below the radar, and it also helps bring in all additional dependencies that are still beneath your radar. So it's sort of a compounding issue, if you will. So we see more and more unpatched vulnerabilities associated with jQuery. Every year, we see jQuery being the troublemaker every year. Again, nothing to knock jQuery. It's just sort of the nature of how it's maintained. Now, this doesn't make these issues any less severe, though. It actually just leads to plenty of opportunities for exploit, right? Because, again, JavaScript is the most popular open source language. I forgot who said it once, but I heard it and I loved it. And it's that if something can be written in JavaScript, it will eventually be written in JavaScript, right? So 75% of the code bases that we looked at contain JavaScript, and 42% of those code bases contain jQuery. So they're super, super popular. So if I put my tinfoil hat on here and sort of try to call attention to any folks on this webinar here. If you're using JavaScript and jQuery and you're building web applications, you should probably be doing a solid audit, one-time or continual audit of your code bases to understand exactly what is impacting your code bases and what vulnerabilities might be lingering around, because I think there's a big lack of understanding there. So if I put my tinfoil hat on, I say, are web applications a major concern, right? Is this all going to fall apart at one point in time because all of these vulnerabilities that are lingering around? It really just takes one vulnerability that impacts a large set of code bases, and it's discovered by the wrong person. And we could be in a world of trouble, especially because these applications, by definition, are internet web connected, right? They're web applications. Now, before I move on to the actionable part of this webinar, I want to point out one issue that doesn't get as much press, publicity, attention because it's not as exciting as security issues, but it is just as much, if not more important, and that is IP obligations of open source. So obviously, open source is free from the monetary sense, but it is not free from intellectual property obligations. And those obligations are overlooked. Now, licensing isn't going to mean a lot to every open source user, depending how they're deploying or distributing their application, right? So if you're building an enterprise application, you probably don't care about licensing. If you're building a SaaS application, you care about it, but not as much. If you're distributing your application, you should care very, very, very much about license obligations, right? It all depends. But regardless, IP compliance is still a struggle, right? Almost a third of the code bases that we analyzed contained either no license or custom license. Now, custom licenses are just hard to really follow correctly. No license is just a huge issue in and of itself, right? You have to be licensed specifically to use something. The analogy I like to use is if you're driving your car and you're pulled over by the police, the first question they usually ask is, can I see your license? You would never turn to them and respond, well, nobody told me that I couldn't drive, right? You have to be explicitly licensed to drive. Same here. You have to be explicitly licensed to use an open source component, and that comes with different requirements. Like if I have to drive on my license, it says I have to wear these because I am blind as a bat without them. Open source licenses say you might have to include attribution in a notices file, or you cannot alter the software. You cannot use it for commercial needs and so on. So this lack of misunderstanding is leading to that figure, and almost half or over half of the code bases that we're analyzing conflicting somehow with the open source that they're leveraging and that they're depending on. I mentioned earlier, AI coding assistance is not making this any easier. This is making this a much bigger, much more prevalent issue, because it's just making it a lot easier for open source to flow into an application without the license context. So, these AI coding assistants will bring in those lines of code, but they are not bringing in licensing headers. They are not bringing in the type of license and the version that you need to be adhering to. So please do not overlook license concerns and IP obligations, again, depending on how you distribute applications. So I am going to run in a second here. What can you do? How can you avoid being a number in our next OSRA report, right? How can you avoid being one of those stats that I put up on a slide and I present next year in our OSRA webinar, right? What can you do to stay ahead of these issues? And before we do that, we have one more poll again to see maybe what folks are doing here already today. So how do you manage your development team's open source usage? So either, and for those who say you're not using open source, that's fine. Either don't answer it or put what you're doing to make sure you're not using open source. Put what you're doing to make you so confident that you're not using open source. So you're either you have policy, or you do not have any policies or tooling in place. You kind of just let your development teams run wild. You might have some manual tracking, like you're asking your open source developer or your developers to manually track the open source, and then you send it over to a legal team or a risk management team, and they just give it an okay. Could be using a mix of manual and automated methods, or this is all automated for you. You are using tooling, using software composition analysis, You're doing policy integration with your DevSecOps tools, your IDEs, and whatever it may be. So hopefully I kind of hit a good mix here of different approaches. All right, we got our results. Okay, 17%, we do not have any policies or tooling in place. Okay, 11% manual tracking and policy enforcement. 50%, a mix of manual and automated methods. Excellent. And 22%, automatic dependency identification and policy enforcement. Fantastic. Hey, these are great numbers. This actually gives you a really good idea of where folks are at. It's tough, you do a webinar, it's hard to read the room. You don't know what's resonating or not. So these polls are great. They help me kind of understand where my audience is here. There we go. All right, enough of breaking the third wall there. All right, so let's dive in. Let's start with establishing visibility, right? And more specifically, establishing visibility with software composition analysis, because this is SCA was purpose built for this very reason, right? This SCA goes all the way back when people were trying to keep open source out of their applications. Then they realized the vast benefits of open source, because I am a big proponent of open source usage. They realized the vast benefits. So SCA pivoted more towards how can we use open source safely and securely and learn to live with it in harmony. And the original focus was actually license. Not until recently did we get into security. So again, SCA is purpose built for this. Now, I mentioned way earlier in the session all the different avenues for open source to find its way into an application. So SCA, well, some SCA tools, should account for all of those different avenues. So there's the most simple way is dependency analysis to identify direct and transitive dependencies just by reading the artifacts of a package manager, like a pom.xml or a package.json file, which will get you 75% of the way. But there's other aspects, other avenues that you have to consider. You have to consider those compiled languages like C and C++ that don't use package managers. You have to consider third-party libraries that you don't have source code for. You have to consider how your development teams might just be bringing in snippets of code manually or with AI coding assistance. So you definitely need different scan types in order to account for all of that. Then when you get these different scan types finally aligned or finally in place, you have to tune the analysis, right, to fit directly into your SDLC. Right? You have to meet at the intersection of accuracy and efficiency. We understand, every SCA vendor understands that your job is to build software, right? Even if you're on a security team, you're on a security team because somebody's building software, right? At the end of the day, the end goal is build software. Now, slowing down innovation and development at the cost of security may sound good. It may sound reasonable and rational, but it very rarely goes over well with development teams. It very rarely even goes over well with business leaders because, again, the security is not making them money. It's the software, right, and the business that the software supports that's making them money. So you have to be able to build these different types of analyses directly into your SDLC so that you're not slowing down development, right? Dependency analysis is very lightweight. This can take place anywhere and it can be done very, very quickly. But as you start to look at code signatures to find open source in C and C++, as you start to want to analyze binaries post-build and do a snippet analysis, then you have to start adjusting where in the development lifecycle, the application lifecycle, where you're going to start having these scans take place because they do take longer and they require access to different parts, build tools. Binary analysis can't be done pre-build. It has to be done post-build. But if you tune it correctly, then your development teams barely even know that you're running these types of tools. And you are getting the most accurate results, and you are building the most accurate dependency inventory and software bill of materials, if you will. Now, after you get these insights, after you get that visibility, it's time to make it work for you. You have to make it actionable. You need some sort of way to tie it back to areas of risk, security risk, component health risk, like identifying those outdated, unmaintained, unused components in versions so that you can cut down on the bloat, which is a very forward-looking investment because the less bloat, the less unnecessary dependencies that you do have, the easier it is to actually manage all of your actual useful dependencies. And of course, you need to help understanding legal open source licenses, IP obligations. Now, this isn't as straightforward as I may have just made it sound. This requires very, very rich data sources to identify open source dependencies, especially ones that are not explicitly declared. It takes vast, rich resources to understand the legal obligations associated with each and every license. And there are thousands of different types of open source licenses. And most of the times our AppSec teams, our development teams, they don't have that legal expertise in-house. And there's no resources to have a in or even out-of-house counsel evaluate every open source license that might impact a specific code base. So you do need to consider how you start to tie back your dependencies to area of risk. And finally, if you're building software, especially as a vendor, not just as a vendor, but especially as a vendor, you need to start thinking about perpetuating software supply chain visibility. And that's all going to operate around a software bill of materials. Now, open source, as I mentioned way earlier, is very important. It's a huge part of software supply chain, but it's not all about open source dependencies, right? An accurate software bill of materials means all dependencies from all third parties, all different suppliers. So if there are some sort of custom or commercial components that are being built into an application, let's say some sort of driver for embedded software, whatever it may be, those do need to be included so that you can accurately identify risk and communicate that down to your own consumer. Then you have to find ways to keep that SBOM continuously updated. Ideally, you build it into your SDLC, like I just mentioned in 2 slides ago, right? So you have a dynamic generation. So every time a new application is built, you've got a brand new SBOM that aligns directly with that specific version of that application. It's up to date, right? We have new transitive dependencies. We have a new version of a dependency. That SBOM accurately reflects it. And of course, you need to find a way to make that software bill of materials actionable. So if you see in the news that Apache Log4j 2.12 has a critical vulnerability associated with it, you need a way to query all of your SBOMs that you have stored that reference all the different versions of all the different applications that you might have out in production. And you need to understand very quickly which of those applications are impacted by this specific dependency. And this is all about the storing and querying and just general SBOM management, not only for your own internal purposes, but also for the purposes of, again, perpetuating that visibility down to your customers and building and establishing trust with them as well. So that is all that I have. I'm going to open it up here to questions, but thank you everybody for taking the time to listen to me ramble on and on about open source software.
Oh, of course, of course. We have got plenty of questions, so I will also just give out one more call. Send in your questions. We're going to start tackling them from the top. So, Mike, let's go ahead and answer Detlef's question. I'll put it up on the screen so you can read along as well.
Great.
And this is in reference to, I believe, a slide you showed earlier that discussed 526 open source components. Essentially asks, is it different by using Linux, derivatives, Windows, Mac OS?
Yeah, I mean, it very well could be. So which could lead, admittedly, to a bloated number, because that number of dependencies might not ship with any given application. Again, depending on the environment that the application is going to be deployed in. We see context-specific application or dependencies all the time, right? Your example was perfect one, right? Is this going to be running on Mac? Is this going to be running on OS? Is this going to be, it's going to be running on Mac, Windows, Linux. And it actually, that's actually even what makes tracking dependencies in C and C++ so difficult as well, is just the way that they link back to these dependencies and the way that, hey, we're going to find a lot of false positives here because this is accounting for both Windows and Linux, and we don't want to have to surface ones if this application is targeted for just Windows or something like that. So yes, that number will include all of those different dependencies, regardless of the targeted deployment environment. But great question, Detlef.
Thank you so much, Mike. Leaning right into our next question from Lynn, what are the primary challenges organizations face when it comes to managing security risks associated with open source software?
So number one is, first of all, identifying the dependencies to the vulnerabilities to begin with. So most of those numbers we're finding of those vulnerabilities, I would venture out to guess that the code bases they came from, that application owner just doesn't know that they're impacted by that vulnerability because they don't know they're impacted by that dependency. Second one, I would say, is prioritizing vulnerabilities. So, I mean, there are so many vulnerabilities that are disclosed on a regular basis. Some of them aren't even really vulnerabilities, especially if you're getting from GitHub security advisories. It might not really be a vulnerability. Kind of just anybody can post those. You don't have to be a certified numbering authority. So it's easy to quickly get overwhelmed by the number of vulnerabilities and start wasting your time on the ones that don't have much impact. Right. So prioritizing which ones to fix first is very, very challenging.
All righty. Our next question from Cassie asks, do you have a preferred SCA tool or an SCA tool that you have good success with?
So full disclosure, Synopsys is an application security company, and we sell software composition analysis tools. So yes, I do have a preferred software composition analysis tool for our users who are distributing applications, and they are a lot more sensitive to license compliance risks and a lot more sensitive to identifying almost all dependencies. And a lot of times the type of software that they're distributing is embedded, like C and C++. I recommend Black Duck software composition analysis. Black Duck, like the bird, quack, quack. A lot of success with that. We are a leader, in the industry, identified by Forrester themselves. For our customers who are building more enterprise and SaaS apps or cloud-based apps, we have our Polaris software integrity platform, and we have SCA on Polaris as well. And that is a lighter weight SCA, but it still identifies all of our customers' dependencies and helps them manage those dependencies, manage the vulnerabilities, prioritize the vulnerabilities, gives remediation guidance. It's just a lighter weight SaaS-based version of Black Duck, although Black Duck can be run hybrid, on-prem, hosted, all of that.
Awesome. Thank you for that, Mike. Looks like we've got two questions from Steve C, and they are both pretty impactful questions. So I'm going to put them up on the screen so that we can read them together. Open source software can have many issues, such as unmaintained or outdated software, uncertain long-term sustainability, inconsistent quality, and publicly available source code open the door for attackers. What would be the best practices to mitigate such risks or vulnerabilities? Would Gen AI analysis be useful to help mitigating the risks? So that's our first Gen AI question of the day.
Wow, took long. Yeah, so Steve, the best approach is going to be sort of, as I mentioned, start with visibility. You have to understand exactly what's impacting your organization, understand which dependencies are being used, and make sure that you have all the data of the three big main areas of risk associated with each one of those components, which is vulnerabilities, license, and operational risk, which speaks to the quality aspect of it, if you will. And then you focus on, or you can do it before you get this visibility, then you focus on policy. You have to understand exactly how much risk your development teams or your entire company is satisfied with. So if I have a company that's building an application that will never be connected to a network, then I don't care about license risk. I might not even care about some security risk. On the flip side of the coin, if I'm a financial institution and I'm connecting with my customers via web portal, then I'm very concerned with security risk. If I'm building embedded software that I'm going to be shipping or building into an infotainment system in an automobile, then I'm very concerned with license issues, right? Once you start distributing. And then now with network connected devices, our network connected vehicles, now there's even more of a security concern. So it all depends on what you're building and who you're going to be servicing. And that's going to help define that policy. So that helps you define what to do with your findings when you eventually get them. Oh, and there's a question. I'm sorry. Would Gen AI analysis be useful to help mitigating risk? We use AI to help bolster our findings. It's just about putting it in the right context. I could go down a rabbit hole with that, but Gen AI is great for building software and analyzing software, and that's something we're behind as well.
Well, I think Steve wants us to go a little bit down that rabbit hole, so I'll go ahead and put his next question up on the screen. It says, Gen AI is no doubt impressive, but it could lead to a few issues such as incorrect facts, biased opinions, can be corrupted by manipulating the data used to train the model, can lead to security threats such as prompt injection attacks or data poisoning attacks. How can Gen AI be employed to mitigate those known risks?
I'm just rereading. Okay, so it seems like the question here is saying Gen AI can be not only exploited, but how do we use Gen AI to detect the exploitation of Gen AI? It's a great question. I don't have an answer for you right now. If I did, then I'd probably go build it by myself and retire early. But it all comes down to looking at a built application, right? So if Gen AI is going to be exploited to produce poisoned results, if you will, malicious code, bad software, then the best time to catch that is during a build, so you can actually identify how data may run through a specific application, see what sort of dependencies might be called in, if they're calling out to remote IPs, whatever it may be, right? The patterns of bad code and vulnerable code still exist, whether Gen AI wrote them or not. So the issues are not unique. It's just a new way to get to the issues. And most SCA solutions, static analysis solutions, dynamic solutions are still going to be able to identify these. So automated tooling is the way to go.
Awesome, Mike. Thank you so much for that in-depth answer. Let's take a step away from Gen AI and return to a couple of different questions. How often do we need to run dependency checks?
Up to you. I would do it. I mean, there's IDE plugins so that whenever a developer is going to be pulling in a dependency, they can actually get a green light or a red light based on your policy. Hey, this has a vulnerability over a certain vulnerability or severity threshold, so we say no. Or this has a specific license associated with it, so we say no. So you can do it at that point in time. You can do it at the time that you're actually merging your code from a working branch into a, let's say, build branch or release branch. You could do it when the software is being actually built. You can even do it after the software is built and it's sitting in a binary repo, and you do a binary analysis on it. So you can do it whenever you want. How often? Again, it depends on your team's structure and your risk appetite. I would recommend doing it on every version of every application at least once before it goes out the door. And I would do a source analysis and a binary analysis. Because after something is built, there can be a lot of other dependencies that are resolved and different sensitive secrets that you don't want shipping that could have made their way in, and you want to be able to identify that. So that's what I would recommend. But again, it really depends on your workflow.
All righty. Well, Mike, in the chat, we've got a little bit of a conversation going on between Anthony and Detlef. But I think the root of the conversation here is kind of what proportions of closed source versus open source should we kind of be looking at to use, especially now knowing that a lot of closed source software is full of open source code. So do you have any kind of opinion on that closed source versus open source debate?
Build only what you have to. There's no reason to reinvent the wheel just because. If your risk management team says they don't want open source and you have to reinvent the wheel, fine. That's fine. But if you have policies and tools in place to identify and manage open source risk, then I say use it as much as you can. It's a fantastic productivity booster. It helps get our products to market faster. And that's why there's tools that help you do the management aspect of it, even if you don't really have a solid built out application security team. So I don't think there's a sweet spot of ratio. Obviously, if you're building software for your business, there's probably at least some of it that has to be proprietary, because that's what makes that software unique and innovative, especially if this is sort of a vendor supplies commercial off-the-shelf software. But stick to that. I mean, use as few amount of resources as possible, and when you are, then do it for innovation. Closed source code, yes, a lot of it has open source, as we saw. Those are all commercial applications that we audited, which is why you need to be pushing your vendors to understand what they're doing to keep that software secure and keep track of it. So ask them for software bill of materials. Onboard your own SBOM management tool or SCA solution so that you can import an SBOM, analyze it for dependencies, and if there are any vulnerabilities, then you go back to your vendor and you say, what are you doing about this? Is this patched? What's a workaround? When are you shipping a new version with the patched version of that? Keep them honest, right? Obviously, as you see from this, there are tools. So if your vendor is selling software, it's their responsibility to make sure that they're keeping that open source managed properly.
All right, Mike, it looks like we've got time for one more question, and it comes in from Raymond P. That says, are the CISA, as the CISA website for the government CISA office, is it still a good reference for vulnerability visibility in products? And what do you use to stay up to date with vulnerability visibility?
Yeah, so let's see, there's the CISA KEV, the known exploitable vulnerabilities. Yeah, that's good. But the thing is, I mean, that'll be comprehensive eventually. It takes time for things to get analyzed and put into that database. Same with the National Vulnerability Database, which is actually seeing big time lags right now. So time is everything when there's a new vulnerability that's been disclosed. Imagine if you didn't know about Log4Shell until 3 weeks later. That's an issue. Yeah, Anthony, CISA is 30 to 60 days behind reality. That's an issue. This stuff is pressing. So that's where, I would recommend you use some sort of, any software composition analysis tool is going to have a vulnerability database. And a big selling point is getting these vulnerabilities getting you alerted of these vulnerabilities within a few hours of the disclosure. And that's going to be possible. But I think the last part of the question is, how do we do it? What sources do we use? We look at hundreds, if not thousands, of vulnerability feeds. We look at hundreds, if not thousands, of forges. We have automatic web crawlers that actually crawl all of these feeds, and they identify these issues that have been reported, right, on Red Hat, on GitHub. And then we take all these and we actually have a dedicated team of professionals that lay eyes on the most sufficient or the most impactful ones. And they do their own analysis of it to make any information more accurate. They assess their own scores and they get that out to our customers as soon as possible. So we do a mix of scraping the internet and then also our own proprietary research so that we can get the big vulnerabilities to our customers' screens within 4 hours of disclosure.
Awesome. Well, Mike, we are at the top of the hour, and I assume you and or our audience might have another meeting or appointment to get to. So I want to be mindful of time. Thank you so much for joining us here on Techstrong Learning. It's been such a pleasure learning from you over the past hour and then an hour in the green room before we went live. It was a pleasure to speak with you today, Mike.
Yeah,
So,
likewise.
thank you.
Thank you. And thanks everybody for joining.
Awesome. So before I officially release our audience, a couple of final reminders. Today's session was recorded and we will be sending you the recording here shortly. You can also find it on the Security Boulevard website. That's securityboulevard.com/webinars. I'd like to thank everyone for their chats and questions. Those have made you eligible for our $50 Amazon gift card giveaway. But it is not too late to click the link at the top of the chat or in the handouts to our post-webinar survey. We'd really love to hear your feedback about our program. We'd always like to tweak and improve our programming going forward. So please do let us know there. Additionally, I would like to thank Synopsys for sponsoring our program today. And last but not least, thank you for joining. We appreciate you and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day and you may now disconnect. Thanks again, Mike.